Hi, my name is Nurfahiza Machim from Group 3 of Mechanical and Electrical System. Today we're going to present about our project titled of Sustainable Mechanical Ventilation and Air Conditioning Proposal for Residential Building. This is the member of the project. The first one is Aman Amira. The second one is Ain Shazana. Next, Nik Ahmad Hakim. Next one is Nur Audi Zeti. And the last one is me, Nur Fahiza Mitimachim. In modern construction industry, achieving comfort while minimizing energy consumption has become a major focus, especially in residential building. Mechanical ventilation and air conditioning (MVSC) system play a crucial role in maintaining indoor air quality and thermal comfort. However, without proper design, this system can lead to excessive energy use and environmental burden. Therefore, it is essential to propose solutions that are not only technically efficient but only sustainable. This project aims to design a complete MVSC system for a proposed two-story residential house. It included the selection of appropriate ventilation system for the kitchen and bathroom, as well as the sizing and selection of sustainable air conditioning unit for living and bedroom spaces. Passive design strategies will also be incorporated to reduce the cooling demand. All decisions will be supported by calculation, real product data, and technical justification to ensure the proposed solution are both effective and feasible. There are 5 main objectives of this project. The first one is to propose a sustainable mechanical ventilation system for specific area in a residential building, namely the bathroom and kitchen, in compliance with the required air chain rates. Second, to calculate cooling load for selected residential spaces and recommend appropriate air conditioning system based on these values. Next, to compare and select real-time market products that meet both technical and budgetary requirements. The fourth, to identify the integrate at least 2 passive cooling strategies to reduce mechanical cooling dependence and improve energy efficiency. The last one is to enhance student knowledge and skill in M&E coordination, focusing on sustainable residential building design. In many residential buildings, mechanical systems are often installed without proper assessment of actual need, resulting in oversized or inefficient equipment. This leads to increased energy consumption, highly electricity bill, and greater environment impact. Additionally, limited awareness and application of passive design strategies contribute to unnecessary reliance on mechanical cooling. There is a need for a well-integrated design approach that combines effective mechanical system with passive design to improve energy performance and indoor comfort. Hence, this project addresses the challenge of designing an energy concierge MVAC system by incorporating calculate cooling load, market research, and sustainable design principles for a residential building.
Hi everyone, today I'm going to explain briefly about mechanical ventilation. First, mechanical ventilation is an engineered system designed to maintain good indoor air quality. It helps to remove stale air, odor, grease, and extra humidity, especially in areas that damp or polluted. Common examples include exhaust fan, range hood. Next, let's look at the importance in bathroom. Bathrooms usually have high humidity, which can cause mold and mildew if not properly ventilated. By using mechanical fan, we can expel excess moisture and bad smells. This helps to keep air clean and help prevent damage on the building structure. Lastly, in the kitchen, mechanical ventilation is equally important. Cooking generates smoke, steam, odor, and grease particles. Without proper ventilation, this can affect indoor air quality and comfort. Range hood and exhaust fan help to capture this pollutant and control grease buildup and reduce fire risk. Let's compare two popular toilet ventilation fans, Panasonic FV20TGU and KDK20AQM8. Both are Japanese brand with strong airflow of over 530 meter cube per hour. Panasonic is a ceiling-mounted fan which price between 170 to 200 ringgit, while KDK is a wall-mounted fan at a more affordable which 110 to 145 ringgit. Panasonic consumes slightly more power and produces moderate noise at 51 decibel, while KDK is quieter at only 37 decibel. Both are energy efficient. Panasonic offers a durable motor with Q-blade design, while KDK features are automatic shutter with thermal safety fuse. Now, for kitchen ventilation, we compare the Keihan EF1201 and Mistral MEF121. Both are wall-mounted propel fans, ideal for large kitchen and small restaurant. They provide strong airflow with Mistral slightly stronger at 987 meter cube per hour. Mistral is a bit pricier but consumes slightly less power and has slightly less noise. Keihan offers good value with strong airflow and built-in features like safety fuse and oil tray. Mistral, made in Malaysia, is optimized for hot and humid conditions and run efficiently with minimal extra noise. Now let's look at the air change rate or ACH, which tells us how many times the air in a room is replaced per hour. For toilet, with a volume of 19.79 cubic meter, the Panasonic model achieved 26.78 ACH, while the KDK model slightly outperformed it at 27.19 ACH. Because KDK is also quieter, cheaper, and more efficient, it's the recommended choice. For the kitchen, we evaluate both wet and dry kitchen type. In the wet kitchen, which 32.74 cubic meter, Keihan gives 30.05 ACH, while Mistral offers 30.15 ACH. In the larger dry kitchen, which 45.64 cubic meter, Keihan provides 21.56 ACH and Mistral gives 21.63 ACH. Despite the small difference, Mistral MEF121 is recommended due to its better airflow, lower noise, and more efficient energy use.
Okay, Assalamualaikum. My name is Nam Akimini Azman. So I will present about air conditioning system. Air conditioning is really important for keeping indoor space comfortable, especially in a hot and humid country like Malaysia. So, in this project, we focus on designing an energy efficient MVAC system for 3 specific rooms, which is master bedroom, study room, and living room. We start by calculating the cooling load for each room to understand how much cooling power was needed, and then we search for a real air conditioning unit that match those needs and stay within our budget. For the bedroom and study room, we choose wall-mounted split unit because they are efficient and easy to install. But for the larger living room, we went with a cassette type unit which provide better airflow and coverage for a big space. Okay, next, we move to the summary of the cooling load calculation and the air conditioning unit selected for each room. For the master bedroom, the total cooling load is estimated around 15,166 BTU per hour. So, we recommend a unit with 18,000 BTU per hour capacity, which is roughly equivalent to a 2.0 horsepower unit. The selected model is the Sharp 1.5 horsepower inverter, which is efficient enough to handle the load and suitable for the room size. Next, for the study room, the total load is about 11,019 BTU per hour, so we recommend a 12,000 BTU per hour or 1.5 horsepower unit. Again, the Sharp 1.5 horsepower inverter is the best fit because of its energy efficient and affordability. And finally, for the living room, The cooling load is much higher, around 25,100 BTU per hour. So, due to the large area and number of occupants, the recommended capacity is 24,000 BTU per hour. So, we decide to use 2 units of the Hisense 1.5 horsepower cassette air conditioner. Each unit provide 18 BTU per hour. So, combined, they can cover the load more effectively. Next, this is comparison between the two air conditioning model that were selected, which is the Sharp 1.5 horsepower wall-mounted unit and the Hisense 1.5 horsepower cassette type unit. The Sharp unit has cooling capacity of 12,000 BTU per hour, which make it suitable for a medium-sized room like master bedroom and study room. It is rated 5-star for energy efficient and use JTAG inverter technology, and also it is easy to install on the wall, and the price range is also quite affordable between RM 1,350 to RM 1,900. On the other hand, the Hisense cassette unit offer a higher cooling capacity of 18,000 BTU per hour, which is better for a larger space like the living room. And it is used R32 inverter technology, which is environmentally friendly and energy efficient. This unit is installed in the ceiling, so it requires more effort and space to install. The price range is similar between 2,300 to 2,500. So overall, each unit has its own strength depending on the room size and installation need. That's all from me. Thank you.
Next, I will explain about cooling passive strategy. First, we use cross ventilation. Cross ventilation is a natural way to cool a houses by letting fresh air in and pushing hot air out through windows or vents on opposite side. It works because one creates pressure that moves air through the rooms. This is more effective if windows are placed at the front and back of house. In two-story houses, it works even better when windows are on both the lower and upper floor, so hot air can rise and escape. To make it more effective, doors should stay partly open and windows should follow Malaysian usual wind direction from the northeast and southeast. This helps keep the house cooler and improve airflow without using fans or air conditioning. Second, we use external shading. External shading is a simple way to keep a house cooler by blocking sunlight from entering through window and glasses door. In a hot country like Malaysia, strong sunlight can make room very hot if not protected. Shading tools like overhang, awnings and louvers help by blocking the sun, especially in the afternoon. They create shadow on walls and windows, which help reduce heat inside. Overhang can be built to match the sun's direction, and louvers can let in light but block the heat. Material like strong wood, metal or UV protector fabric make shading works better. Plants like beech trees or climbing vines also give shades and make the home cooler and nice to look at. Next, I will explain about advantages for use cross ventilation. First, lowers indoor temperature naturally. Cross ventilation brings in cool air from outside and pushes hot air out through window or vent on the opposite side. This flow of air helps cool down the house without needing fans or air conditioner. It works well during hot days when the temperature inside rises quickly. This method keeps rooms more comfortable using only natural light. Second, enhance air quality indoor. When air moves through the house, it helps remove the dust, smell, and extra moisture. This makes the air inside fresher and healthier to breathe. It's helpful for people who have allergy and breathing problems. Good airflow also stops mold from growing in humid areas. Third, improve thermal comfort. A steady breeze makes the room feel cooler and less stuffy. This is important in hot and humid places like Malaysia, where heat can build up inside. Air movement helps people feel more relaxed even without air conditioning. It's improved comfort without needing extra energy. And for the last, environment friendly. Cross ventilation does not need electricity, so it helps save energy. It reduces how often you need to use air conditioning or fan. This means lowers electricity bills and less harm to the environment. Next, advantages for use external shading device. First, minimize heat from sunlight. Shading tools like awning louvers and roof overhangs stop direct sunlight from entering through windows. This keep room cooler by blocking the strongest heat, especially in afternoon. When less sunlight enter, the house stay more comfortable. This is great for houses with many windows. Second, reduce cooling energy demand. With less heat coming in, air conditioning does not need to work as hard. This saves energy and reduce electricity costs. The indoor temperature stay cooler for a longer time. Shadings help cut down the use of mechanical cooling system. Third, enhance privacy and comfort. Shading device also block glare from the sun while still letting lights inside. They give privacy by limiting how much people outside can see into houses. At the same time, they keep the space bright and pleasant. This makes the room more relaxing and useful. And for the last is protect surface and material. Too much sun can damage wall, furniture, and other indoor material. Shading protects this item from UV ray and heat. It also shields windows and outer wall from the rain and weather. This also helps the house look better from longer and safe repair costs.
Next, this is our final layout and illustration for the floor plan. So we propose the mechanical ventilation at bathroom and kitchen with the exhaust fan in the symbol with the blue color. And for the air conditioning with the green color there, we put at the bedroom, living room, and dining room. Next, this is the elevation plan for the project, which shows the exterior view of the building from different angles. It helps visualize how the building will look from the front, back, and sides. Then this diagram shows the cross-section of the building, illustrating how ventilation system works. The key idea is to ensure proper airflow throughout the house to maintain indoor comfort, especially in a hot and humid climate. As you can see here, cooler air enters through the lower openings such as the timber doors and aluminum frame windows. Hot air, which naturally rises, escapes through the exhaust fan and lowered opening at the top of the building near the roof, promoting a continuous flow of fresh air. Next, the cross ventilation is achieved by aligning openings on opposite side of the space, allowing air to pass through efficiently. For discussion, this project shows how important it is to use sustainable design when planning MVAC system for homes in Malaysia's hot and humid weather. We studied the building layout, calculate how much cooling is needed, and compare different products to find the most efficient and practical solution. For ventilation, we choose energy-saving fans like the KDK20 AQM8 for bedroom and the Mistral MEF121 for the kitchen. This was selected based on airflow, fire operation, and cost. For air conditioning, we made sure not to oversize the units by using accurate cooling load calculations. For example, the Sharp AHX15 BED is suitable for bedrooms, while the Hisense cassette inverter is better for larger spaces like the living room. We also use passive cooling methods like cross ventilation and shading to reduce the needed for air conditioning. Overall, this approach helps save energy, lowers electricity bills, and keeps the home comfortable. It's smart and environmentally friendly solution. To conclude, our project successfully designed a sustainable MVAC system for a house. We use smart planning, energy-saving products, and eco-friendly ideas. We didn't just rely on air conditioning. We also use natural ventilation and shading to keep the house cool and save energy. This helps the environment and keeps the house more comfortable. We also learn a lot how to work as a team, think critically, and use real data for better design. Overall, our system is suitable for Malaysia climate and it shows how students like us can help build greener homes. Good buildings come from good people and all problems are solved by good design. That's all from us. Thank you for watching.